Let's look at examples of how to use graphing techniques to transform a graph. For this, we're going to transform this graph using several different transformations. So for our first example, if this original graph is f of x, we're now going to graph negative f of x on the same graph. So remember, this negative out in front means we should reflect this graph over the x-axis. So first we need to identify points that we can use in our transformation process. And with a graph like this, it's good to take like endpoints and points where the graph is turning. So for example, this point, a second point here, third point here, this fourth point, and then this endpoint. So these 5 points I'm going to reflect over the x-axis. So this first point on the left will reflect over to here. The second point reflects to here. The third point reflects here. The fourth point reflects over the x-axis to here. And the fifth point reflects over the x-axis to here. And now I'll connect those points in the same order. So 1 to 2, 2 to 3, 3 to 4, 4 to 5. And there's my graph reflected over the x-axis. So here's the graph of negative f of x. So let's look at one more on this same coordinate plane. Let's graph f of negative x. So the negative inside the parentheses with the x means to reflect the graph over the y-axis. So again, I'm looking at the very original graph in black. So I'm going to take those same 5 points and now reflect them over the y-axis. So the first point, the very first one on the left, will reflect and then the second one reflects here. The third one, it might be hard to see because it's on that line. Third one over here. And then the fourth one. And then if I connect them in order, 1 to 2, 2 to 3, 3 to 4, 4 to 5. And in purple, we have the graph of f of negative x. Okay, let's look at a few more. I'm going to have this same original one again. I don't want to do too many on one coordinate plane because then it gets a little confusing to look at. Let's now look at the graph of f of x plus 3. So this plus 3 on the outside means to translate up 3 units. If this had been f of x minus 3, we would be going down 3 units, but we've got plus 3, so we're translating up 3 units. So all 5 of my points we're going to move up 3 units. So I've got my first point, my second point, my third point, my fourth point, my fifth point, and then if I connect them in order, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and the blue graph is my graph of f of x plus 3. Let's also look at f of x minus 4 with the minus 4 in parentheses with the x. And this is going to be translating the graph 4 units right. If this had been f of x plus 4 in parentheses, then it would be translating 4 units left, but it's minus 4 in parentheses. So from that original graph in black, we'll translate all of the points 4 units right. So my first point, my second point, which is on that line, so it may be a little hard to see. Third point, fourth point, also on that line, a little hard to see. And then the fifth point, I needed to plot out a little bit because it goes off the coordinate plane, but that last one is a point. And then let's connect it, 1 to 2, 2 to 3, 3 to 4, 4 to 5, and then in green we have the graph of f of x minus 4 in parentheses. Let's look at a few more. So let's look at the graph of 1/2 f of x. And this 1/2 out in front of everything is a vertical compression. If I were graphing 2 f of x with the 2 out in front, that would be a vertical stretch. but a 1/2 would be a vertical compression. So this means we're going to move all of our points half the distance they are from the x-axis. So the first point, I'm moving it in closer to the x-axis, half the distance. There's the first point, there's the second point, there's the third point, there's the fourth point, there's the fifth point. So again, we're compressing it towards the x-axis. And now connecting them in order, 1 to 2, 2 to 3, 3 to 4, 4 to 5. And in red, we have our graph of 1/2 f of x. Also on this graph, let's look at f of 2x with the 2x in parentheses. That 2 is a horizontal compression. If it had been f of 1/2 x with the 1/2 x in parentheses, that would have been a horizontal stretch. Here, we are having the distance to the y-axis this time. So we're compressing it towards the y-axis. So each of those 5 original points on the black graph, we're compressing them closer to the y-axis. So the first point comes in here. The second point comes in here. It's a little harder to see because it's on the line. There's the third point also on the line. There's the fourth point, and the fifth point will also be on a line, so it's a little harder to see. Let's connect 1 to 2, 2 to 3, a little hard to see, 3 to 4, 4 to 5. And that purple graph is our horizontal compression. Okay, let's kind of combine several of these all together. So we're going to look at the graph of 1/2 f of x minus 1 plus 3. So in general, we could have a of f of b of x minus c plus d. And when we have multiple transformations, we do need to go in a order. We would look at horizontal stretches or compressions first. And if we had reflections over the y-axis, we would do those at the same time as well. Then we would do horizontal translations. Then we would do vertical stretches and compressions and reflections over the x-axis. And then finally, we would do vertical translations. So we will do our translating right one, then we will do our vertical compression of 1/2, and then we will do our vertical translating up 3. So for this first point, I'm moving it right 1, and then I'm compressing it towards the x-axis. So let me erase my first one. And then we're moving this point up 3. And I'll erase the other intermediate point. So this is the new position for that original first point. For that second point on the original black graph, okay, I'm moving it right 1. I'm compressing it towards the x-axis. And then I'm moving it up 3. For the third point on the original black graph, I'm moving it right 1. I'm compressing it towards the x-axis. And then I'm moving it up 3. For the fourth point on the original graph, I'm moving it right 1. I'm compressing it towards the x-axis. And then I'm moving it up 3. This one is actually in between lines because the compression was putting it at 2.5 up on the y-axis. And when I moved it up 3, it's still in between 2 coordinate lines. And then that last point, move it right 1, so it's actually off the coordinate. It's at a new grid line. Compress it towards the x-axis, and then move it up 3. So I have my 5 new points. Let's connect them. 1 to 2, 2 to 3, 3 to 4, 4 to 5. And that's my new transform graph of 1/2 f of x minus 3, 1/2 f of x minus 1 plus 3.